They are staples on many bucket lists, and these natural beauties have been captivating humanity's imagination for millennia. But have you ever wondered how the night sky transforms into a canvas of mesmerizing dancing lights? Hi there, and welcome to Gimme 2. My name is Mark, and in this video, we will explain auroras in just 2 minutes. As with my other videos, if you want to go straight to the 2 minutes, which discusses how the auroras become visible to us, that is timestamped in the description. But if you stick around for a couple of minutes before that, I go through some of the fundamental science and other context regarding auroras that might be worth a listen. Auroras are brilliant displays of colorful lights throughout the night sky that are generally visible in and around the Arctic and Antarctic regions of the planet. They can appear in a variety of different ways, from a faint glow on the horizon to dancing curtains of bending lights that cover the night sky. They get their name from the Roman goddess of dawn, named Aurora, and they come in two practically similar varieties. Aurora borealis, aka the Northern Lights, named for the Greek god of the northern wind, Boreas, and Aurora australis, aka the Southern Lights, named for the Greek god of the southern wind, Auster. Northern Lights are better known simply because more people live in the areas where they can be seen. On Earth, these aurora are visible under certain conditions at night and are tied to solar activity and their interaction with our atmosphere, with stronger solar activity associated with more frequent and stronger lights. We can track the probability of seeing aurora by using the K or KP index, ranging from 0, meaning very low, to 9, indicating severe geometric disruptions caused by solar activity. Auroras have been interpreted quite differently throughout history, ranging from those who believe that it's the reflection of a herring shoal, indicating a good fishing season in Sweden, or the sparks from the tail of a celestial firefox, to the spirits of ancestors. And documentation of aurora goes back close to 3,000 years, with our oldest documented mention emanating from China. In order to understand how auroras work, it might first be helpful to understand magnets. Yes, magnets. Atoms, which make up the physical stuff in the universe, consist of charged particles, most notably positively charged protons in the nucleus and negatively charged electrons that orbit those nuclei. When a charge is in motion, such as the orbit of an electron around a nucleus or the spin of an electron during its orbit, it generates a magnetic force called a magnetic moment. Most atoms have low or no magnetism because the magnetic moments generated from some electrons are negated by the opposite motion of other electrons. Some atoms, however, like iron, cobalt, nickel, or gadolinium, have unpaired electrons, and their magnetic moments are not negated, resulting in atomic magnetism. When such atoms come together, they form distinct north and south poles within the material, creating what we call magnets. So we live on a magnet. Earth's core, which is made up of magnetic iron and nickel, is in constant motion. This generates magnetic poles, our north and south pole, and it acts like a generator, which we call a dynamo, creating a powerful magnetic field called the magnetosphere. This literal force field surrounds our planet, protecting us from solar winds, creating an atmosphere that is conducive for life. And auroras. Now that we have some context on what auroras are, and some of the foundational science that play into our seeing them, let's go to the 2 minutes which explains how they come to be. Before we do, however, if you find this video interesting, entertaining, or just plain informative, please consider liking and subscribing to the channel in order to stay up to date with similar informative videos. It also helps the channel grow, and videos like this to reach wider audiences. But now, let's get back to the 2 minutes and the auroras, starting now. The journey of the auroras starts at the sun, but not with its light. Atoms at the surface of the sun get extremely hot, transforming them into a charged gaseous state of matter called plasma. These charged particles ride along magnetic fields near the sun's surface, forming coronal arches. Due to shifting magnetism, these arches can snap, shooting off incredible amounts of plasma into space, called coronal mass ejections. These CMEs travel through space as solar winds, and if they reach Earth, they interact with our magnetosphere, which I discussed in the context. In most cases, these particles are deflected around the planet. But if solar activity is strong enough, it can cause disruptions to our magnetic field near the poles where our protective force is weaker. The stronger the activity, the further from the poles it can disrupt. These disruptions can snap the magnetic field lines, and the charged particles can ride those field lines into our atmosphere where they interact with Earth's gases. During these interactions, plasma collides with nitrogen and oxygen in our atmosphere, exciting those atoms, making them unstable in the process. As they stabilize, these gas atoms give off photons in the form of light, which brings them to our eyes. The wavelength, and therefore color, of that light depends on the gas atoms and where on the atmosphere they are when they shed the photon. But when those interactions are strong enough, they create a brilliant light show that has drawn spectators north, or south, for hundreds of years. And that is how auroras come to be. I hope you enjoyed that video. I found it very interesting researching this topic, and I hope I was able to deliver that information clearly to you. If you found it interesting, feel free to comment below on a topic that you might be interested in, and who knows, maybe I'll research and make a video on that. Thanks for watching, and I hope to see you in another video.